All right, guys, here we go with our last set of organic chemistry notes. Sorry they're not as quality as usual, but I'm running out of time and didn't feel like editing with the green screen, so here we go. This last set of notes is about a number of different special functional groups that we haven't talked about yet, but play a really important role in a lot of different chemicals. So let's get going. Start off with, we have alcohols. These are straight chain alkanes with an OH group. Side note, I'm going to keep all of these examples just to the alkanes. I don't want to overwhelm you, and I'm not going to ask you questions about anything more than that because it gets really complicated when we have to number where these functional groups are, along with where the double or triple bonds are too. So we're going to stick to the KISS method here and keep it simple, stupid. So for alcohols, this is where we have an OH group attached to one of our carbons. You would name the straight chain molecule as normal and replace that final E with OL so that ane becomes anol. If there's 3 or more carbons, like if it's prop or bigger, you have to specify which carbon that hydroxyl group is on. So for methanol, since we only have 1 to choose from where that OH is going to be, it's just methanol. For ethanol, either carbon we put it on is going to be carbon number 1, so we just call it ethanol. But then any more than that, like propanol here, we have to specify because we have a choice. We can have it on the carbon at the end, that'd be 1 propanol, or if we had an OH here in the middle, that would be 2 propanol because it's on the second carbon. Ethers are when you have an oxygen instead of an OH group. Well, better yet, this is where you have an oxygen within your chain of carbons. So you'll have a carbon chain on either side of your oxygen attached to it. So to name these, you just name the 2 alkyl groups that are attached to that oxygen in alphabetical order, and then follow the name with ether. So in this case, we'd have, since there's 2 methyls, it's dimethyl and then ether. Over here, there's 2 ethyl groups, so it's diethyl ether. And then over here, you've got a methyl group and an ethyl group, so name those alphabetically. That gives you ethyl methyl ether. For aldehydes, this is characterized by an oxygen that it's double bonded to a carbon, which we call a carbonyl group. And then we have at least 1 hydrogen attached to that carbon. So if we have a double bonded oxygen and at least 1 hydrogen, that's 3 of our bonds out of our 4 already taken up. So no matter what, this group here is going to be on the end of our chain. To name these, name the parent chain as normal. Since that CHO group is at the end, there's no reason to number it because we know it's always at the end. And then you change the E on the ending to AL. So instead of methane here, meth because there's 1 carbon, we call it methanal. And then ethane would turn into ethanal. Propane would be propanal. And this guy over here, you kind of had a choice. You could have called it 2-ethyl propanal, but the longest chain we have is 4 carbons. So it's actually we'd start carbon here, 1, 2, methyl butanal. Ketones are straight chain alkanes with a double bonded O group somewhere in between. This is kind of like our carboxyl or our aldehydes here, but instead of an H, we have another chain of carbons. So for our ketones, you name the parent chain as normal, change the ending E to an ONE, so the ane becomes anone. And then at the beginning, if you need to, basically if it's more than 4 carbons, you need to specify where that double bond is attached to, double bonded O is attached to. So for propanone, there's 3 carbons here. Since that this can't be on the end, ketone groups are never at the end because that would have us an aldehyde. If it's at the end, it's an aldehyde because there's an H. This one doesn't have an H to the carbon. It's a carbon with two other carbons and then a double bonded O. So we don't have to specify it if there's only one choice. In fact, for butanone, we don't even have to specify it if there's two choices, because no matter what, that's going to be carbon number 2. But when we get over here to 5 carbons, we could have put it on carbon number 2 or 3. So here we had to specify that it's on 3 pentanone. For carboxylic acids, this is kind of similar to what we've just been talking about, kind of more similar to the aldehydes, but instead of an H, it's an OH group there. So we have a double bonded O and an OH group attached to our carbon. These are always going to be at the end of our carbon chain. So name the carbon chain as normal, replace the E at the end with oic, so that ane becomes anoic, and then end the name with acid. So we have 2 carbons here, that'd be like ethane, but it's got the double bonded O and the OH, so it's called ethanoic acid. Over here we have 4 carbons, so it'd be butane, but there's the double bonded O and OH, so it's butanoic acid. Esters, again, more of these similar things. Actually, these are like our let's see, these are like ethers, because it's got this O with carbons on either side, and our ketones, because it's got a double bonded O. So it's kind of those combined together. So for esters, we got a double bonded O, and then one of our ether groups with that O there. We're going to name the parent chain that's attached to the double bonded O group, change the E at the end of that to OH, so that ane becomes anoate, and then name the alkyl group on the other side of the O at the front. So over here, our chain attached to the double O is propane, because there's 3 carbons. Change the ending of that to OH, so it's propanoate. And then on the other side of our O here, that's an ethyl group, so it's ethyl propanoate. This guy is just a methyl group attached to our double bonded O, so it's methanoate. And on the other side of our O is 3 carbons, so it's propyl methanoate. And let's see, now you can see that. This one's got 4 carbons, so it's butanoate with a methyl group over here, so it's methyl butanoate. And then this one would be ethanoate with a propyl in front of that, so propyl ethanoate. I think this might be our last slide here. Yep, sure is. Amines. You've kind of run into these a little bit before when we talked about our benzene molecules with an amine group attached to it. But in this case, this is just a straight chain with an N attached to it somewhere. So to name these, we just name all of the alkyl groups that are attached to our nitrogen in alphabetical order, and then follow the name with amine. So here we've got 2 methyl groups, that'd be dimethylamine. This one's got 2 ethyl groups, so it would be diethylamine. You could have 3 alkyl groups attached to that N. You could just have 1, and it could be NH2 at the end. All you have to do is just name all of the carbon chains attached to the N, and then follow it with amine, and that's the name. I know this was a lot to take in, and it's a little bit confusing, but you'll see these rules on that one green document we have with all the rules for naming. And then we'll do some practice tomorrow and Thursday over this. If you have any questions, please let me know.